guys, welcome back to my channel JK Maths. Today we will be completing the chapter Polynomials, which is the easiest chapter which could be completed within half an hour or 45 minutes. So let's dive into the chapter. First exercise. The graphs of the y is equal to p of x are given in the figure 2.10 below for some polynomials. Find the number of zeros of the p of x in each case. So let's find. So before jumping into the question, we should learn that number of zeros can be found by only the line which cuts the x-axis. That is, the number of times the line cuts the x-axis is known as zeros of the polynomial. Let's see. See, in the first subdivision, you can see this is the line. See, I am marking it. This is the line. So the line, how many times it cuts the x-axis will be the number of zeros of the polynomial. So this line is lies on y-axis, so it doesn't cut x-axis. So there won't be zeros. So 0. The number of zeros for this is 0. Let's see the second subdivision. Here the line crosses the x-axis only one time. See, it crosses here. So number of zeros for this polynomial is 1. See, 1. It's easy, right? So let's go to third one. See the line. It goes like this. See, number of times the line cuts the x-axis. This is called x-axis. See, I am marking the yellow line. This is called x-axis and this is called y-axis. Now the red line is the line with the imaginary line. The red line cuts first time, second time. I'll mark it with another color. First time, second time, third time. So 3. So number of zeros will be 3. It is nothing but the line cuts. Number of times it cuts the x-axis is known as the zeros. Those are zeros of the polynomial. Fourth one, see, the line cuts one time and second time. See here. So number of zeros for this is 2. So let's see here. This is the line. Number of times it cuts is 1, 2, 3 and 4. So number of zeros will be here is 4. Again see here. The line cuts here one time, second time and third time. So only 3 times it cuts the x-axis. So number of zeros is equal to 3. So that's it. It is nothing but the line, how many times it cuts the x-axis will be the number of zeros. Hope you understand. Let's go to the second one. So this is the second sum. Find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. So a quadratic polynomial is given, so we should find the zeros from them and we should verify the relation between zeros and the coefficients. So first our step is to find the zeros of the quadratic polynomial. So first subdivision is so x square minus 2x minus 8. So to find zeros of this, first we should take this key points. So first we should write product. Product is nothing but a into c, because this quadratic polynomial is always written in the format of ax square plus bx plus c. Always it is written in this form. So a into c. So coefficient of x square is 1 and c is minus 8. So we'll be getting minus 8 and sum is b, that is minus 2. So we got this two. These two are most important for finding the zeros of the polynomial. So now we will be finding the zeros. We got product as minus 8 and sum as minus 2. Now we will be finding the zeros. First in the uppercase, so we should write product in the up and we should draw a simple rhombus by drawing like this, leaving simple gap between these two lines. In down case you should write the sum of the polynomial. Now to find zeros we should assume two numbers. Here see, we should fill these two gaps. So we will be assuming two numbers. So that we should assume two numbers such that if we multiply both of them we will be getting minus 8, and if we add them we will be getting minus 2. That we should the answer should come, so that there will be the zeros of the polynomial. So I am repeating it. We should assume two numbers so such that if we multiply both of them we will be getting minus 8, and if we sum them we will be getting minus 2. So let's go. So what are the numbers? We can take 2 4s or 2 4s or 1 8s or, so these are the possible numbers. So if you first take first case, if we multiply 2 into 4s or 2 4s are 8, we will be getting 8, and if we subtract them we will be getting 2. So since the signs are not convenient for us, we can change the signs for them. So if we sum them we should get minus 2. If I put minus in place of 2, we will be getting plus 2 as sum. But the only thing is we should put minus in the place of 4. So I am putting minus in place of 4. So if we add them we will be getting minus 2, and if we multiply them we will be getting minus 8. So this will be our possible number. So we can easily neglect the second set. So 2 into minus 4, this will be your zeros. So these are the possible numbers. Okay. No, so these are not actually the zeros. We should add with x. So x plus 2 is equal to 0. Actually the zeros must be in the form of this, and x minus 4 is equal to 0. So if we take 2 that side we will be getting x is equal to minus 2, this is, and if we take the second one x is equal to 4. So these are the two possible numbers we will be getting in the place of x. So the first one you can take it as alpha, and second one you can take it as beta. Yeah, we got the zeros minus 2 and 4. Now we will be seeing the relationship between them. See, we got alpha as minus 2 and beta as 4. Now to find relationship we should draw a simple line. See, like this we should draw. Here we should write zeros, and here we should write coefficients. So we should set the relation between them. That's the question, and we have to prove it. Zeros and coefficients. So to find the relationship we should use product and sum of the polynomial. So for zeros we got zeros as alpha and beta. So these are the zeros, alpha and beta. So alpha and beta are the zeros of the polynomial. Okay. The general form is ax square plus bx plus c is equal to 0. This is the general form. So to find the relation between them we should first take the sum of the zeros as well as product of the zeros. So for first sum we will be adding two zeros, alpha plus beta, that is minus 2 plus 4. We will be getting plus 2. And here the coefficients, how to find sum? So to find sum we have a formula, that is sum of the polynomial will be equal to minus b by a. See the question, this is a, b and c. So the coefficients of x square, x and constant is the a, b, c respectively. So here a is 1, b is minus 2, c is minus 8. So for sum we should take minus b by a, that is minus b is minus of minus 2, b is minus 2, so minus of minus 2. Now divided by a is 1, so is equal to 2. So we have satisfied the sum of the zeros. Now we will go to product. This will be your sum. Now it will be a product. Product of zeros is multiplying two zeros, both the zeros, alpha into beta. That is nothing but minus 2 into 4. That is will be minus 8. So if we take in place of coefficients, there is another formula. So product of the zeros of a polynomial will be equal to c by a. This is the formula, c by a. So here c is minus 8 and a is 1. So minus 8. So both sum and product are satisfied respectively. So henceforth, so we can write there is a relation between zeros and the coefficients. We can end with that. That's it. Let's go with the second subdivision. 4s square minus 4s plus 1. Here in the second subdivision they have just changed the variable, that is in place of x they wrote a yes. So let's go. In the same way we should first find the zeros and then prove the relation between zeros and the coefficients. Let's do. So for our sake I will be doing, I have done first sum and I will be doing second sum, third sum and fifth sum. So fourth and sixth you can write as a homework. It is a simple one, as like as a first and second sum. So the only thing between 3 and 5 you will be confused. So I'll be teaching that in a easier manner. So let's go the second sum. The second sum is 4s square minus 4s plus 1. So product, first thing is you should find the product and the sum of the polynomial. So product will be equal to AC. This is A, B and C. AX square BX plus C. Okay, this is the format. So here AC is 4 into 1. 4 into 1, that is 4. And sum will be B, that will be equal to minus 4. Okay. Yep. Let's draw the rhombus. So product. So first we should write product and draw a triangle and leave a space, and in down case you should write minus 4. First we should take all the possible outcomes. Possible outcomes. We should assume two numbers such that if we multiply them we will be getting 4, and if we sum them we will be getting minus 4. So only the possible digits will be 2 into 2 and 1 into 4. So 1 into 4 we can neglect easily. If we sum them we won't be getting 4, because the difference is only 3. So we should take only the possible set 2 into 2. So such that their product should be 4 and plus 4, and sum must be minus 4. So here if we multiply we will be getting 4 plus 4, it is satisfied, but if we sum them we won't be getting minus 4. So in this case we should change the sign. So if we change only for minus 2, first 2, if we sum them we will be getting 0, and if we product them we will be getting minus 4. So if we should change both the signs such that minus 2 and minus 2. If we product them we will be getting plus 4, and if we sum them minus 2 gives you minus 4. So x that will be equal to that will be equal to x minus 2 equal to 0, again x minus 2 equal to 0. So what we are getting, the assumed possible outcome should be the 0. The opposite of the opposite sign of the number will be the 0. So we took minus 2 and minus 2. So these are the possibilities. We should change the sign. That is, if it is minus 2 we should change plus 2 and plus 2. So this will be the zeros. For your more convenience, if you want to get extra marks you can write like this. So x is equal to 2 and again x is equal to 2. So this will be our alpha and this will be our beta. So next will be verification. So now verification, zeros, okay, zeros and coefficients. Okay, we got alpha as 2 and beta as 2. Okay, first sum will be your thing. Sum, first we should sum it and then product to verify it. So for sum we will be getting alpha plus beta. So 2 plus 2, that will be equal to 4, and alpha plus beta for coefficients, it will be a formula minus b by a. So b is minus 4, so minus of minus 4 by what is your a, that is 4. So minus of minus 4 is plus 4, 4 by 4 is 1. Sorry, yeah. Oh, I'm sorry, extremely sorry guys, wait for a second. I'm extremely sorry. So actually we got minus, we took this as assumed one, so minus 2 and minus 2. So here we have to do one thing. See, we took 4 and minus 4. Here we done like this. So here we took minus 2 and minus 2, minus 2. So here we should always check a, that is ax. See, we took minus 2 and minus 2. So we should always check a, that is ax. So in last sum we got a as 1, so we won't care about that. So here we got a as 4. So if a is 4, we should the assumed number should be divided by 4. See, divided by 4. Always after finding the assumed numbers, we should check the a. If a is 1, leave as it is, because minus 2 by 1 will be minus 2 only. So if it is other number, you should divide it. So we got a as 4, so we should divide the my assumed number by 4. So if we divide this, we'll be getting minus 1 by 2 and minus 1 by 2 here. Now we will be taking x. The zeros will be opposite sign of this. So 1 by 2 and 1 by 2. For your convenience, you can write x minus 1 by 2. X minus 1 by 2 is equal to 0. So these are the alpha and beta. And I'm extremely sorry for the previous one. So now there will be clarity. So we got alpha as 1 by 2 and beta as 1 by 2. So now we should verify the relation between zeros and coefficients. Zeros, coefficients. For zeros, we should first do the sum and then product. This is the thing we should find to verify them. Leave a line. So for zeros, to find sum, we will be adding both the zeros, alpha plus beta. 1 by 2 plus 1 by 2. So after taking LCM, the answer will be 1. Am I right? Wait for a second. Yeah, I am right. So to find for sum for coefficients, we have a formula alpha plus beta is equal to minus b by a. Minus b by a, that is b is minus 4. So minus of minus 4. So if we take a, we will be getting 4. So minus of minus 4 plus 4, 4 by 4, 1. So now it is satisfied. Previously it doesn't satisfy because we didn't divide the assumed number with 4. So now product alpha into beta, that is 1 by 2 into 1 by 2, that is 1 by 4. Now the sum is already satisfied. Now we are checking for product. So to find product of coefficients, we have another formula, c by a. So here c is 1 and a is 4. So hence both are satisfied. Let's check the third sum. Hence proved. Let's go with the third subdivision, 6x square. For this sum, most of the people will be confused. How to do the sum? 6x square minus 3x. So actually the question is in wrong format. So what I said, the general form of a quadratic polynomial is ax square plus bx plus c. This is the general form of a quadratic polynomial. Am I right? So this is the quadratic general form. So the given question is not in that format. See, we got ax square, right, it is right. Bx, the bx is not here, it is in the place of c. The c is in the place of b. So we should change the order. So let's change it. So 6x square minus 7x minus 3. I'm just changing the order. Now it is possible to find the zeros. So for finding zeros, first product, that is AC, A into C, that is minus 3 into 6, that will be equal to minus 18, minus 18, minus 18, and sum will be B. B is minus 7. Am I right? Yeah. Now let's find the zeros. So first product, and down sum. So we should assume two numbers. So what we can take 3 6 or 18, 2 9s are, yeah, we got that. This is the one. So why I am directly taking 2 9s are because if we multiply them, we'll be getting 2 9s are 18, and if I sum them, we'll subtract them, I will be getting 7. 9 minus 2, 7. So I can easily neglect 3 into 6. So but it is in the minus sign, so we should change the sign. To do this, if I put minus in the place of 2, if I product them, we'll be getting a if I put minus in the place of 2, if I product them, we'll be getting minus 8. But if I subtract them, sum them, 9 minus 2, I'll be getting only plus 7. So I can't put minus in the place of 2. So I'll be putting minus in place of 9. So if I put after summing that, I will be getting minus 7, and if I multiply it, I will be getting minus 8. So I will be taking 2 into minus 8, minus 9, sorry. So opposite sign of these assumed numbers will be your zeros. So x plus 2 is equal to 0. So x is equal to minus 2, that will be your alpha, and x minus 9 equal to 0, and x is equal to 9. So this is your alpha and this is your beta. Again I'm sorry guys, I'm sorry, very sorry. So we didn't check the A. So last time I said that after getting the assumed numbers, we should just divide by A. So I forgot to divide it. Okay. I'm sorry, extremely sorry. Okay. So minus 9. So now we should divide by a. So a is nothing but has 6. We got a as 6. C here a x square. So divide by 6 divided by 6. So that will be equal to 1 by 3. Oh, sorry. 1 by 3, and this will be equal to minus 3 by 2. Minus 3 by 2. So opposite signs of this will be your alpha and beta. So then that will be equal to minus 1 by 3 and 3 by 2 will be your alpha and beta. So this is your alpha and this is your beta. Now let's check the relationship. Okay. We got alpha as minus 1 by 3. Alpha is equal to minus 1 by 3. And beta is equal to 3 by 2. Now we should check the relation between them, zeros and coefficient. Okay. For zeros, first we should take sum, and then product. This is the only way you can check the relation between zeros and coefficients. Product. Okay. Got it. Now for zeros, to find sum we should add both the zeros. It is 1 by 3 minus 3 by 2. Since plus into minus, so I am directly writing it as, so we should take it. Okay, that will be equal to minus 7 by 3. So wait for a second. Sorry, minus 7 by 6. Yeah, the answer is minus 7 by 6 for this. So if we take for coefficient alpha plus beta, there is a formula, right? Minus b by a. It is here b is 7x. A is here a, b and c. B is minus 7. So minus of minus 7 divided by a, that is 6. So minus of minus is equal to 7 by 6. Wait for a second. Here we got 7 by 6. Oh, sorry. Actually, so this is, I'm sorry. This is plus 3 by 2 and this is minus. This will be plus. Okay. Also plus. So the sum is satisfied. Now let's go to product alpha into beta equal to alpha into beta minus 1 by 3 into 3 by 2. So if you do that, 3 cancel, that will be equal to minus 1 by 2. So this is your product for zeros. If you take for coefficients, this is a formula c by a. So what is c? Here c is minus 3 and a is 6. That will be equal to minus 1 by 2. So hence satisfied. Let's go to the fifth sum. Fourth and sixth you can try it as a homework. It is a easier one. So in fourth sum you should take constant as 0 and you should do as usual. Let's go. Now fifth sum, t square minus 15. So here they are given only a and c. So t square minus 15. So we got only ax square and this is c. We haven't got a bx. This is missing. Am I right? Bx. Only we got a, x and wait for a second. So the question is t square minus 15. We got only A is ax square, that is t square, plus the b is missing, so minus c only we got only c. These two are the things we got. We didn't get bx. So if a variable is not given, we can assume it as a 0. So let's see how it is. So we can assume it as t square plus 0.t plus minus 5. See, they are given only t square and minus 15. So the b term is not given, so we can assume it as a 0. See, now it is satisfying the general form ax square plus bx plus c. Here a will be 1 and b is 0 and c is 5. So we got a form. Now let's do the sum. So there is a simple method for this. Is see, we can t square minus 15. You can, if you observe cleanly, you can see a formula, that is a square minus b square is equal to a plus b into a minus b. Am I right? So this you can if you observe this, you can observe. So this can be expressed like this also, a square minus b square. To express like this, we got t square, but there is no square for 15. So to do that, we can write 15 like this also, root of 15 square. So root of 15 square is equal to 15 only. So we can write 15 like this, root of 15 square. So t a plus b, that is t plus root 15 and t minus root 15, a minus b, root 15. So is equal to 0. So t is equal to minus root 15, that is opposite of this numbers, and t is equal to 15, root 15. This is alpha and this is beta. Now let's check the relationship between the zeros and coefficients. So alpha is minus root 15 and beta is root 15. Yes. Coefficients. Okay. First sum and product. Okay. Let's check the relation. So sum of the zeros will be that is adding both the zeros, minus root 15 plus root 15, that will be equal to 0. If you take coefficients, formula is minus b by a, that will be equal to here we took b as 0.t, bx is equal to 0.t, so that will be equal to minus 0, a is 1. So here no need to divide by a. Here there is no need for the assumed number to be divided by a, because here a is the coefficient of a is 1. So 0 by 1 is equal to 0. The sum is satisfied. If we take for product, alpha and beta is minus root 15 into root 15, that will be equal to minus 15. So root into root will be cancelled, and 15. Okay, minus 15. Again there is a formula for product, c by a. C by a, c is minus 15 and a is 1. So minus 15, hence satisfied. So first sum is over. Let's go to the second sum. So second sum is the last sum of this chapter, and by this we'll be completing the entire chapter of polynomials. It is the easiest chapter, and examples you can write as a homework. If you cannot do it, you can refer my videos for a clear reference. Tomorrow we'll be starting with linear equations. So let's complete this chapter within 10 minutes. Yeah. Here, Find a quadratic polynomial each with given numbers as sum and product of its zeros respectively. So here they are given the zeros. So we should find a polynomial. Means here they given as zeros. We should find the polynomial. In previous sim they have given a polynomial. We should find the zeros. Here it is a reciprocal of it. They have given the zeros. We should find the polynomial. So let's start. So generally there is a formula for finding a quadratic polynomial. That is k of the k is constant, k of x square minus sum of zeros plus product of zeros, that is k is actually constant, x square minus alpha plus beta plus alpha beta. So this is your general formula to find a polynomial using zeros. So actually in the question I am wrong. Actually they are given a sum and the product of the zeros. So these are not zeros actually, these are a sum and the product of zeros respectively. So see the question first sum. First question is 1 by 4 comma minus 1. So actually this is minus 1 by 4 is sum of the zeros and this is product of zeros. Minus 1 is product of zeros. See sum and product of the zeros respectively. So 1 by 4 is sum and minus 1 is product. So sum they are given as 1 by 4. Sorry. Sum is 1 by 4 and product is minus 1. So we knew the formula, that is x square minus alpha plus beta and alpha beta. This is the formula to find a polynomial. So we knew that k should be written as always constant. So x square minus alpha beta is given, that is 1 by 4 plus 1 by 4 minus x square minus 1 by 4 x. Here we have to write x plus minus 1. So why we are writing ax is because the general form of an quadratic polynomial is ax square plus bx plus c. So in here we are writing as x. So this is the required polynomial. So second subdivision. Okay. So second is alpha plus sum is root 2 and product is 1 by 3. So formula is k into x square minus alpha plus beta plus alpha beta. So this is the formula. So k into x square, here x minus alpha beta is alpha plus beta is root 2 x plus alpha beta is 1 by 3. So here the denominator is 3. We should not actually leave the denominator as it is. We should take the LCM and cancel the denominator. That is, if we take the LCM, we should multiply all the ax square and bx into 3. So 3x square minus 3 root 2x plus 1 by 3 into k. K is constant. Actually we can k is constant, so we can cut k and 3. So if we assume k as 3, we will be cutting k and 3. K and 3 will be cancelled. So the required polynomial will be 3x square minus 3 root 2x plus 1. So this is the required polynomial. Okay. So third one is alpha plus beta is given as 0 and alpha beta is root 5. So formula is k into x square minus so here alpha plus beta plus x into plus alpha beta. So k into x square minus alpha plus beta is 0 point x. So you should not write directly 0x because it won't mean. So you should write 0 point x plus alpha beta is root 5. So so we can leave 0 as it is. So 0 is not countable. So required polynomial is x square plus root 5. So this is the required polynomial. Writing k is optional. You can either write k or leave as it is. So this is the required quadratic polynomial. Let's go to next sum. So the fourth sum is 1, 1. So here they are given us fourth sum, alpha plus beta is 1, alpha beta is again 1. So formula k into x square minus alpha plus beta into x plus alpha beta. So k into x square minus 1x plus 1. So since 1 is coefficient of x is 1, we can either write 1 or leave as it is x. So leaving k x square minus x plus 1. So this is the required polynomial for the fourth sum. Let's go to the fifth sum. Fifth one, alpha plus beta is given as minus 1 by 4 and alpha beta is again 1 by 4. Formula k is k into x square minus alpha plus beta x into x plus alpha beta. So formula, this is formula. So in the steps you should write k. K is the important one. If you leave this, your teachers will be cutting off a mark. So k is important one. Don't forget to put that. So x square minus alpha plus beta. So first we have to add it. Okay, 1 minus 1 by 4 plus 1 by 4 x plus alpha beta is minus 1 by 4 into 1 by 4. Sorry, actually I'm sorry, I mistake. Alpha plus beta is minus 1 by 4 x plus alpha beta is 1 by 4. So x square minus into minus plus 1 by 4 x plus 1 by 4. If we take LCM, we will be getting s. Okay. After taking LCM, the required polynomial will be 4x square plus x plus 1. This is the required polynomial. So this is the required one. That's it for today's class. You can try sixth sum as a homework. It is the easiest one. So with this we have completed the polynomials chapter. So tomorrow we'll be going with the next chapter, pair of linear equations. Okay, take care. Bye guys. Please don't forget to subscribe my channel and share this video to all our 10th graders. Thank you. Bye bye.